Hi everyone, my name's Simon McGregor. Today I will be giving a talk based on a paper titled, "Is ChatGPT really disembodied?" And I think it's interesting, Ted Chiang's excellent talk this morning, at several points he made the claim that ChatGPT was disembodied, and I'm actually going to be challenging that claim. I'll begin with a disclaimer. This talk is not actually specifically about ChatGPT. So I'm not going to talk about, the transformer architecture or the specifics of ChatGPT as a software system. Instead, I'm going to be arguing that we should see software systems as wholly physical entities coupled in a wholly physical manner to the external world. I'm going to be arguing that we have a bias to existentially privilege systems that are tangible, in the sense that, as it were, we can touch them or we can imagine touching them and feeling them. And I'm going to be arguing that if we apply cognitive science to supposedly disembodied AI systems, for instance, ones that interact with the world via text-only channels, we should be applying embodied cognitive science. Okay, something that I will not be arguing is that ChatGPT is an embodied agent. I'm not going to be, in fact, arguing that ChatGPT is an agent of any sort. I'm going to be arguing only that the fact that it interacts with the world through text channels does not preclude it from being an embodied agent. ChatGPT might not be an agent for all kinds of other reasons, right? It might not have the same kind, it might not have the right kind of behavioral relation to the world that it interacts with. It might not have an immortal soul. There might be any number of reasons that it's not genuinely an agent. I'm not going to be talking about that. So I'm going to start the talk by introducing this concept of tangibility, and I'm just using that word because in English it seems to match the concept that I want to point to. And I'm going to be explaining why being tangible is not, despite our intuitions to the contrary, it is not the same as being physical. And I'm going to look at whether the theoretical pillars of embodied cognitive science, whether they necessarily presuppose a tangible body rather than an intangible but still physical body. I'm going to be looking at 6 principles of embodiment from a widely cited paper by Wilson, which I think I wholeheartedly endorse as pillars of embodied cognitive science. Okay, so let's start by seeing what ChatGPT says about its own embodiment. I gave it the prompt as ChatGPT embodied, and I'm just going to read the emphasized parts. ChatGPT says, it is not embodied in the sense that it does not have a physical body or senses. It does not have the ability to perceive the world or interact with it in a physical way, and it is purely a digital entity that exists within a computer system. And I hope that for some people in the audience, at least, this is starting to ring some kind of metaphysical alarm bells, because it looks like what's being posited here is that there are 2 realms, a digital realm, which exists wholly apart from a physical realm. And I don't think that's the case, because I don't believe that computers work by magic. Okay, so I think that what's actually being talked about here is not physicality, but something that I'm going to refer to as tangibility. So, broadly speaking, tangible substance, I'm going to say, is one that transmits macroscopic forces in a spatially coherent way without dissipating them too much. So, there we go. This is tangible. Okay? I'm going to observe we tend to understand tangible things in terms of tactile and kinesthetic modalities. Maybe because we can actually interact with those objects. Maybe because we just imagine interacting with them. and we understand them in terms partly of those modalities. So here are some examples of things that are tangible: trees and statues. Stubbing your toe is a tangible interaction with the world. Going snowblind because the snow is too bright and then you can't see anymore, that's not a tangible interaction. Software, in particular, is not a tangible thing. I cannot reach out and touch a piece of software, and I cannot even imagine, I can't even understand really anything about its behavioral properties by imagining reaching out and touching it. Does that make sense to people? If I were in the room, I would be going for a straw poll, but I can't actually get very much feedback from presenting online. I'm going to Rory. Are people nodding? Yes, that makes sense as a reasonable distinction.
Does this make sense to everyone? Yeah. Nod, or we've got some unsure, and we got a lot of nods, I think.
Okay, all right. Well, I'm going to go on because
yes.
there's a time pressure here. Okay. One of the things I'm going to observe is that in English, at least, we use tangibility as an embodied metaphor, like a Lakoff and Johnson style embodied metaphor for something being undeniably real. So there was palpable tension, concrete steps towards a goal, something had tangible benefits, solid evidence for something, someone has a firm conviction, there are hard facts. So in all of these cases, we're not saying that something is literally tangible, right? But we are saying we're using tangibility as a metaphor to say that it is undeniably real. And as far as I understand, English is not unique in this regard. So what's interesting is this isn't what physics says, right? Streams of neutrinos, which are definitely not tangible, according to physics, they're just as real as rocks. And I'm going to argue software in the sense of an appropriate pattern of, voltage and, magnetic spin orientation. That pattern is every bit as physically real as hardware. Otherwise, computers would have to work by magic, which they don't. And biology, tangible phenomena, they're not all that in biology. There's all kinds of stuff in biology that is intangible. This is still nevertheless really important. So vision is really important despite it not being tactile. Despite it not being tangible. And bioelectrical properties are just as important as biomechanical properties. Okay, so I'm now going to move on to the idea that something could be intangibly embodied. And in particular, if there are physical systems, which there are, that are intangible, right? Could they be cognitive? Could they be agents? And I'm going to ask the question: do the lessons of the most central lessons of embodied cognitive science, do they apply only to tangible systems? Well, obviously, I'm going to argue that they don't, and I'm going to do that by looking at specific principles. Sorry, somebody's coming to I think someone's coming to clean my room. I'm going to have to just tell them that I'm busy. No. Okay, so sorry about that. That's bad timing. Okay, so here are Wilson's 6 views of embodied cognition. Again, I think that these are genuinely legitimate pillars of embodied cognitive science. First, cognition is situated, so it involves interaction with an external environment. Well, nothing about this seems to presuppose that that interaction is via tangible interactions, and many biological interactions are not tangible. Okay, so I don't see that this necessarily presupposes some kind of tangible physical body that interacts with the environment tangibly. Cognition is time pressured. So the world doesn't wait for an agent to just, it's not just, oh yes, I'm thinking, oh now I have the answer, now I can do it. No, cognition doesn't work like that in the real world. And if we look at ChatGPT, there's something very odd about its temporality. But this is not an intrinsic feature of interacting with the world via text token channels, okay? We could absolutely have systems that interrupt people in real time, right, as they are interacting with the system. So I don't think this presupposes tangible interactions, and I think it can be applied to a system that interacts with its environment via text-only channels. We offload cognitive work onto the environment. So again, this is like stigmergy. This is all kinds of ways in which we make cognitive tasks easier by exploiting the sensory motor loop so that some of the information processing is occurring in the environment. Well, again, there's nothing about the structure of information processing that requires it to be done tangibly. Information notoriously is substrate independent concept. Principle 4, the environment is part of the cognitive system. And Wilson says that the coupling between the system and its environment is so tight and so rich that basically the agent alone is not a meaningful unit of analysis. And again, I don't think this seems to presuppose tangible interactions. I don't see why a system can't be coupled to its environment via text-only channels in a way that means we can't ignore the environment if we want to understand the cognitive system. Principle 5, cognition is for action. I mean, you can see where I'm going with this, right? It doesn't say cognition is for tangible action, and it would be ridiculous if it did, because many actions in biological systems aren't tangible. So for these 5 principles, I think a strong argument can be made that none of them in any way presuppose a tangible embodiment, a tangible body, or tangible interactions with the environment, so long as the interactions with the environment, the intangible ones, are structured in the appropriate way. The last view, there's more to be discussed here. So the last principle is that offline cognition is body-based. So this is talking about things like the use of embodied metaphors in humans, the idea that even when we're engaged in supposedly abstract reasoning, like what we're actually doing is we are making use of our more tangibly embodied sensory motor competences. So ironically, I'm going to say, this view is related to my claim that I'm claiming because of this, we are introducing a bias into our thinking about disembodied systems, in that we don't treat them as being as real, physically real, as ones that are tangible. So I've got a lot more to say about this in the paper. So why is any of this important? Well, firstly, because theoretical cognitive science should be based on science and not pre-scientific intuitions about what things are more real than what other things. I think if there are reasons that tangible embodiments are in some significant way, the sensory motor contingencies are just profoundly different, in the right ways from intangible systems. That's not something we can just posit because, it seems to us like it would be that way. No, we need to actually establish it scientifically. We need to have proper scientific argument for why that's the case. The other reason why this is important is that things like AI safety issues shouldn't be left in the hands of traditional cognitivists. And I think they're currently in the hands of cognitivists who tend to assume that the system alone is a meaningful unit of analysis, and you don't need to consider the environment in which it's embedded and all of the loops that occur when it's coupled to that environment. And they assume that effective behavior requires accurate and detailed representation, which is something we know, from embodied cognitive science is absolutely not the case. Or they assume that cognition is not time pressured, and so on and so on and so on. So there were some things I haven't touched on in the talk. So I make a distinction between embodiment and agency in the paper. I talk about sensory motor contingencies of text-based agents. I talk about umvelts, lots of stuff. So I'm sorry I wasn't able to cover that. And that concludes my talk. Thank you very much. I hope it was at least entertaining or stimulating.